Hi, Max and Lola. This is Miss Ellen. I'm going to do some summer math with you because I know you love it. We're going to do difference of squares and factoring trinomials. And I understand that you're already good at FOIL, which is very important to do well at this because it's kind of the opposite. So to show you first difference of squares, the general formula is a squared minus b squared, which means there's two terms, and remember terms are separated by plus or minus signs. So if there's two terms, and the first thing is a perfect square, and the second term is a perfect square, then it factors into two binomials, where you take the square root of this first, and the square root of a squared is a. So a goes in the first. And the square root of b squared is b, so this goes in the last position. And in order to FOIL, so there's no middle term, we'd need 1 plus and 1 minus. So with numbers, if it were x squared minus 49, it is the difference of two squares, because x squared is a perfect square and 49 is a perfect square, and it is a difference. So again, set up your two binomials to start. The square root of x squared is x. The square root of 49 is 7. And one's plus and one's minus, it doesn't matter which you put where. Now sometimes you have to factor out a common factor first. So if you have something like, let's see, I got one over here. You have one like this. Okay, we don't have a difference of two squares because that's not a perfect square and that's not a perfect square. So you're actually supposed to always check for a greatest common factor first. And we have one, it's 2x. And when you factor out a 2x, you're left with x squared minus 1. And then notice that the directions are always factored completely. So it's going to be the greatest common factor, 2x. And then this is the difference of two squares because the square root of x squared is x and the square root of 1 is 1. So we set up our two binomials, and the square root of the first goes in the first, the square root of the last goes in the last, and one's plus and one's minus, and that's factored completely. Here's another one like that. 64 minus 60 squared. So first, you always check for a greatest common factor in which there is one of 6. So my greatest common factor is 6. Then I factor this as a difference of two perfect squares. Again, the two binomials. Square root of 4 is 2. Square root of d squared is d. And one's plus and one's minus. So that's a general idea. I think that on your worksheet, I saw that you did a lot of them. I'm not sure if there's, oh, you have a question on number 12. So I'm gonna do number 12 for you right now on your worksheet. So we have 24x cubed minus 54x. So again, you might recognize you don't have a perfect squares here, but there is a greatest common factor of 6x. Leaving us with 4x squared minus 9. So don't lose your greatest common factor, and this is the difference of two perfect squares. Setting up your binomials, the square root of 4x squared is 2x. First goes in the first. Square root of 9 is 3, so the last goes in the last, and one's plus and one's minus, doesn't matter which. So that's that general idea. You know, they get a little more involved when you get to number 24 on your sheet, but it's still a greatest common factor. So we don't have a difference of two perfect squares here. Notice the exponents always have to be even to be a perfect square. So let's see. 6 is not a perfect square, and if I took out a 2 or a 3, that's not going to be a perfect square left. So I'm thinking 6 probably goes into 216 without knowing ahead of time. So it does, it goes in 36 times. So my greatest common factor is going to be 6. I can take out an A from each, and I can take out a Y from each, leaving me with 36 x to the 4th minus y to the 4th, which, surprise, is the difference of two squares. So again, don't lose your greatest common factor. Set up your binomials. The square root of 36x to the 4th is 6x squared, so that goes in the front and the back. And then the square root of y to the 4th is y squared, that goes in the front and the back, and one's plus and one's minus. Now I didn't do all of your worksheet, but I just wanted to show you one that something that could happen. Oops. So say we had this. Oops, make this a y to the 4th. So if that's y to the 4th, you can factor this as the difference of two squares. The square root of x to the 4th, oops, is x squared. And the square root of y to the 4th is y squared. And one's plus and one's minus. So what you're left with here is still the difference of two squares. So this is x plus y, x minus y, because this is the difference of two perfect squares, square root of x squared being x, square root of y squared being y. And then this is not the difference of two squares, it's the sum of two squares. And so that's not the same, so it stays as that, because there is not a difference of two squares. It's a sum of two squares, and then that doesn't follow this pattern. Actually, you'll learn later on how to do something like this, but right now we're not. So there's that final answer. So let's move on to trinomials. So the easiest ones are in the form when a is equal to 1. These are the easiest. So here are examples of that. Looks like you've done some of them. I'll just write some of them down. It doesn't matter what variable I use. There's one that you did. Here's one that you did. Let's start with this one. So you might have figured this out. So about the signs, but let me talk about the process first. So it's 3 terms. There's always check for a greatest common factor first, which there's not one here among all 3 terms. Remember, terms are separated by plus or minus signs. So we're going to set it up as, I call it reverse FOIL. Textbooks usually just call it factoring trinomials, but it's the reverse process of FOIL. So this times this has to be b squared, right? The first times the first has to be b squared, so obviously that's b and b. And the last times the last has to be 7. Well, luckily 7 is prime, so the only way to factor a 7 is a 1 and a 7, or 7 and 1. Doesn't matter which way in this case. Now, if the last term is positive, these two signs have to be the same, because a positive times a positive is a positive, or a negative times a negative is a positive. But if the middle term is positive, then they're both going to be positive. Because when you refoil it, the inners and outers give you the 8b. So you're basically working for the first term to get it, the last term together, and then making the inners and outers combine to the middle term. So again, if the last term is positive, both factors always have the same sign. In this case, they were both plus because if this is plus. If they were both minus, then it would be because this was minus. If the last term's negative, then they have to be different signs. So again, there's no greatest common factor, so I know I'm going to kind of reverse FOIL it. So the first times the first would be x times x would give me x squared. Now 12 isn't prime, so you might not have to write all these factors down. I'm just going to do this so you can follow my inside head thinking. All the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. and I'm trying to figure out which pairs of numbers, which pairs of factors that multiply to 12 can combine to 4 when the signs are going to be different. So 6 and 2 can give me a 4 if the 6 is positive and the 2 is negative. That'll give me positive 4. So that means I need a 6 and a 2 with the 6 positive and the 2 negative. They have to be different because the last term's negative. But they combine 6x and negative 2x to the positive 4x. Okay. So another one to try. Always check for greatest common factor. There's not one here, so I'm going to reverse FOIL it. How do I know to reverse FOIL it with the 2 sets of parentheses? Because that's always how you factor trinomials. So actually, difference of 2 squares and factoring trinomials factor into the 2 sets of binomial parentheses. So the first times the first has to be k squared, so that's k. The last times the last is 40. So I like to list all my factors. 3 doesn't go in, 4 goes in, and 5 and 8, and then I'm done. Because then I want to look at ones that can give me 13. Now, if the last term is positive, they're both the same, and they're going to be this, negative. So that means they're both negative. So how can they both be negative and add up to 13? Well, 1 and 40 is not going to give me 13. Adding these aren't going to give me 13. Okay, not these, so these. So 8 and 5 are 13. And it doesn't matter which way you write them, like this or like this, because as you know, multiplication can be done in any order. It's commutative. So I like to write all these down, or if you're good in your head, that's good. But sometimes if the number's weird, like you might not think of the factors, you know? So let me try another one here. I don't see any like that. But let me try this. So I just made this one up. So again, there's no greatest common factor. Always check that whenever you're factoring. I can see there's 3 terms, so I'm definitely gonna set up my 2 binomials that will FOIL to give me this trinomial. And the first times the first has to be x, and the last times the last has to be 14. So again, whether you do this in your head, this one's pretty easy, or you write out all the factors, because some of them have more factors than others. Well, if the last term is negative, these 2 signs have to be different. So that means these 2 numbers have to subtract to be 15. Right? Well, 1 and 14 won't give me a 15 if they're different, right? Doesn't matter if I do that, because that'll give me negative 14 and plus 1x, which will give me negative 13x. Or if I did it this way, that won't work either. That'll give me positive 13x when I FOIL it. So I'm not getting the 15. 2 and 7 are never going to give me 15. So sometimes the problem is not factorable. I don't know if you came up with that ever in your life, but it can happen. And so we'll just say it's prime. I just thought I'd mention that to you. I don't know if any of the problems you have that happens, but maybe not. Just thought I would mention it's possible, but it probably isn't going to happen to you yet. Another one on your sheet is this one. So again, no greatest common factor. So 3 terms I set up. N times n is n squared. Now factors of 56. 1 and 56, 2 and 28, 3 doesn't go in, 4 and 14, which is a weird, right? Could be that, but I don't think it is. 5, 6, 7, and 8. So if the last term is negative, they're going to be different signs, which means you're really going to subtract them. So which pair do you subtract and get negative 1? 7 and 8. where the 8 is negative and the 7 is positive. So I hope that helps. Let me know if you need more examples, and have a great time. Bye.